Okay, hi there, sorry it's me again. Final presentation now. We'll just run through a few case studies of industrial clusters. Start with a general introduction and then we'll run through two specific case studies, one UK-based industrial cluster and one based in the Netherlands. So just a brief introduction to some of the UK industrial clusters. So there are a number of kind of large-scale industrial clusters that have been developed within the UK, obviously centred around major centres of CO2 emissions. So you can see the heat map there, which shows where the major locations of CO2 emissions are within the UK, and the clusters that have been developed accordingly off the back of that. So there are two main industrial clusters that have been selected for effectively track one funding from the UK government, i.e. where UK government are heavily supporting the decarbonisation of those clusters. So those are the East Coast cluster, which is a combination of net zero Teesside and zero carbon Humber on the right hand side, and High Net Northwest as well, which is kind of in the middle on the left hand side there. So these clusters have merged over time, and they're a combination of a wide range of industries. So whether it's kind of gas-fired power, refineries, chemicals, cement, waste incinerators, glass industries, etc. It's a combination of a large number of different industries that have got together, collaborated, and effectively formed these industrial clusters, and then are collaborating to seek government funding as part of the wider decarbonisation scheme. So just very quickly running through those in a bit more detail. So would have supported on a large number of these industrial clusters. So we formed the feed on the Acorn carbon capture plant along with Carbon Clean, who are one of the OEMs on that project. And we're currently providing part of the hydrogen system design, looking at how you transport hydrogen from the Acorn cluster down to Aberdeen for use in a wide number of industries. On Net Zero Teesside, for example, we've provided concept engineering and pre-feed design services, and we're currently supporting BP as the systems integrator, providing PMC services and reviewing the feed design effectively for the carbon capture technology, as well as the offshore pipeline infrastructure for the sequestration of the CO2 and the onshore CO2 network as well. And then finally on Zero Carbon Humber, we provided concept engineering and pre-feed design for the Humber Zero portion of Zero Carbon Humber. We're also currently designing the CO2 pipeline network and the hydrogen pipeline network as well, effectively connecting all the emitters and off-takers for the hydrogen, as well as the CO2 pipeline itself. But the key kind of takeaway from this slide deck is really the kind of the master planning and the overall systems integration and coordination that needs to take place with these industrial clusters, and kind of the benefits of scale that you can get when you start to collaborate between different types of industries and bringing in different types of end users. So in order to support that, Wood have developed a decarbonisation model called SCORE, which effectively looks at a full techno-economic analysis of different decarbonisation methodologies and how that could be applied to various industrial clusters. So that offering is split up into three main phases. You've got the advise phase, the assess phase, and the deliver phase. So the advise phase is really around scene setting, understanding targets and requirements, understanding what your benchmarking data is at the moment. And then the assess phase is running through your various technical options, assessing those individually, and performing a full-scale techno-economic analysis on each of those individual options. And then finally, the delivery phase is obviously the implementation of those options, effectively a decarbonisation roadmap that you can then execute over a period of time to achieve your decarbonisation targets. So what does that look like in reality? So this is a greater breakdown of that individual SCORE model itself. So you can see some of the individual components of the advise, assess and deliver phases. So when we're looking at the advise phase, I mean obviously the importance of benchmarking the data and understanding what your current emissions are can't be understated. You need to know what your current emissions are in order to set targets and improve against those. And we can help support clients in that in terms of the wider context and policy, other market impacts that may be having an effect on that. And then take that through to the assess phase. So the SCORE acronym itself comes from substitute, capture, offset and reduce, the E effectively being the evaluation of those. So we look at all of the different options that are available and then assess those, as I mentioned in the technical assessment, to take through to the delivery phase itself. So just to apply that in the context of one of the industrial clusters, so this is a methodology we apply to the Humber Zero network, for example. So in the advice phase, we're looking at the various policies and drivers that are being implemented by UK governments and other industries. Looking at the technical features of the sites, identifying their current baseline emissions, for example, and then effectively setting targets for that industrial cluster in terms of their decarbonisation pathway, what they want to achieve as a project and as a cluster, and setting that target in terms of technical requirements of the project in the early feasibility phases. For the assess phase, we then completed concept screening and selection for each of the individual industries within that cluster. So looking at all the various decarbonisation options that were available to individual industries, whether that was integration of renewables, green hydrogen generation, blue hydrogen generation, simple operations efficiency, for example, in terms of just more efficient operations to drive down CO2 emissions. And then that technical economic assessment to evaluate each of those options for each of the end users and effectively select the optimised solution for each industry as a collective that will give the most overall or highest overall CO2 reductions for the cluster itself. And then finally we took that through to delivery in terms of delivering the full pre-feed design development, updated deliverables in terms of kind of the PFDs, PNRDs, heat balance trading, etc. And running through an updated techno-economic assessment. And we're subsequently taking that through to the next phase in terms of supporting feed as the PMC for the overall cluster, making sure that they deliver on the targets that we set at the start of the project in the assess phase, in the advice phase, sorry. So I think the main kind of takeaway for these slides is that it really is about collaboration. It's about understanding how the cluster works as a whole, understanding the individual requirements of the individual industries, but looking at the optimisation across those to achieve the best collective solution. And when it comes to interfaces, clearly there's a significant amount of interfaces when it comes to these industrial clusters, whether it's kind of the potential store operator if you do need to store any of the hydrogen, for example, whether it's government funding that's coming in from third parties, from government or third parties, whether it's local supply chain, constraints on supply chain, where you're using the materials and balance of plant from, and then the emitters and off-takers themselves. Organising a range of industry users to work together can be extremely difficult, and that is one of the key challenges when it comes to industrial clusters. But the potential benefit of doing that massively outweighs any single emitter working on their own. There's potential efficiencies in terms of supply chain constraints, efficiencies in design, efficiencies in solutions. It can't be understated exactly how important that is, and that's why we're seeing those industrial clusters that have been developed in the UK receiving large amounts of government funding to support those developments, because the efficiencies are clear and the potential to leverage local supply chains is clear as well. So that's the first case study, which was on one of the UK clusters. I'll pass over to Alex now, who will run through the Netherlands case study.